One of the assumptions of linear regression is that there should not be any multicollinearity amongst the x variables in the model. Computing the VIF, also called as variance inflation factor, is one of the very common ways of detecting multicollinearity in the model. Let's continue to work with the CA school dataset. First off, I am creating a linear regression model that includes all the x variables in the dataset. As always, I have also split the dataset into training and test data. Now, this is the coefficients of the model, and we also have the p-values listed. Many of them are not significant, and some of them have incorrect signs. If you look at the correlations, you will find out that the sign of the correlation and the coefficients for some of the x variables do not match. So for those variables, I am first removing those variables. I'm removing str, teachers and computers, and rebuilding the model. And this is the new summary. In this new summary, only cal w percentage is not significant, others are all okay. To compute the VIF, you can use the VIF function in car package. Car is a very useful package that contains helper functions related to linear regression. VIF is one such helper function. Now let me refresh our knowledge on VIF. VIF is nothing but VIF of a variable x1. It could be any of the x variables in your model. It is nothing but 1 by 1 minus r square. This r is not the model r square. This r square is the r square of the model where you are explaining x1 as a function of all the other x variables in the model. If you build a linear regression for this model, the r square for that model would be this one. This is how you compute the VIF. Let's calculate it using the VIF function. If you notice, meal percentage, that is the percentage of students who are eligible for subsidized meals, this particular variable is having a very high VIF. A VIF that is greater than 4 is considered to be very high. Ideally, it should be lesser than 2. In this case, it is lesser than 4 and it is much greater. Now, the next move to improve this model could either be removing cal w percentage or you could remove meal percentage because meal percentage is having a very high VIF. But typically, in most cases, the priority is given to removing the variable that is not significant. So for the next model, I'm removing cal w percentage. You could also try out removing meal percentage. That is no harm in that. But in this case, and in most cases, the priority goes to removing the variable that is not significant. So after removing cal w percentage, we have a nice model where all the variables are statistically significant. Checking out the VIF, we have meal percentage VIF falling below 4. The sign of the coefficients are okay. All the variables are statistically significant and all the VIFs are less than 4. Ideally, it should be less than 2, but it's okay. I'm going to stop here.